Alright, so we'll be looking at the draw sheet, which is the 2025 2026. Okay, so those questions that you have there. Alright, so that is it. Let us now look at the things that are inside. So I'll do it very fast. There is a way I'll operate it in a way that also you need to solve some things. Okay, just to make sure that you are accustomed. So the first one we have is De Morgan. Alright. So I'll solve question 1 if I want, or let me solve question 2. Alright, let me solve question 2, then you solve question 1. So I'll solve B. Alright, so it says, alright, so B, it says A. So De Morgan is about just the effect of the complement. Alright, so for example here we have A complement. Once you distribute the complement inside there, you have A complement. In fact, I don't have to put these brackets. You distribute as A complement. Alright, then the union, now the intersection will change to union. If it was an intersection union, it would have changed to intersection. Okay, so we have left hand side and right hand side. So we'll start with left hand side. So you quote left hand side, okay, to, if you want, okay, to right hand side, okay, if you want. Depends with how you are spicing and how your lecturer taught you. Sometimes you can just start to say rate, okay, all x's. So you can write that word as same as o, okay. Let all x's, okay, be a member of what is on the left. Okay, so on the left we have A intersection B complement, like that. Okay. This means that X, okay, is not a member of, all right, A intersection B. All right, okay, because the complement has moved. This means that now it's no longer a member of that. It was a member when the complement was there. So this means that we can now distribute A complement. X is not a member of A. That intersection is simply means and. Then again, X is not a member of B. Alright. So this means that X is a member of A complement. Okay, then the and which was here will change to O. Okay, X is now a member of B complement. This means that X is a member of A complement union B complement, like that. So that's what we have found there, right? That's what we have found. So this means that from what we have just found as equation 1 here, we can simply conclude to say, therefore, what we started with, that is A intersection B, alright, complement, is a subset of what we have found there. Okay, A, alright, complement union B complement. So this is our equation 1. Okay, so starting again from right hand side to left hand side. Okay, so what you are going to do is we'll say again, let all x's, or let just x, okay, be a member of what we have there on the left. So we have A union B complement, A complement union B complement, like that. Okay, this means that x okay, is a member of, all right, x is a member of, all right, A complement, all right, A complement then this O, it will change to A. Okay, this U union will change to O. X is a member of B complement, like that. So this means that X is a member of, okay, is not a member of A now. and you put and here, the game changes now to and the same X is not a member of B. Okay, this means that X is not a member of, okay, A, then intersection B. Okay, this means that X now will be a member of A, okay, intersection B, then complement, like that. You see, now it's a member after I've added the complement. That's why we are back there on top, if you are able to see here on top here. All right, on top there. Okay, we are back to that equation. So from what you have just seen, like what we have just recorded there, this means that what we have found there, all right, so therefore, all right, therefore, okay, what we have started, you started with A, okay, complement union B, complement, like that. Okay, then it's a subset of what we have just ended up with. So intersection B, complement, like that. So you say from equation, so I'll name this as equation 2. So you say from equation 2 and 1, then A intersection B intersection B complement, okay, is equal to, okay, is equal to A intersection U, then B, like that. Okay, so that is it. So that's how you can summarize that. So hope you can do that. Similarly also, this is a game that is being done there, so that's not a stress. We just want to have time, otherwise there's no work to be done here. There's something to be done ahead. All right, so that is it. So let's go to the next thing. So try to solve this and submit your work. All right, then we have a few questions here. All right, so how can we answer these? So if C and D, I mean if C is a complement of D, then find the following. Okay, if C is a subset of D, so it's more like we have a set there. All right, we have a set there. We have a set there. All right, let me draw a set. Okay, so we have a set there, right? Then we have two sets there, right? So we have set, okay, so we have two sets there. All right, so and also we have set C there inside, then we have also set D. So now how do we approach this? How do we approach this? So we are saying now C is a subset, so we want to intersect now the following. All right, so C intersection D, they will intersect in C there, so we'll write as C just as the answer. Okay, so that would be the answer there, because they were intersected. Then at this point, okay, how can you simplify this? We have C complement, which is outside the S, will report outside. Okay, so you shade like that. Okay, that's the C complement, right? Then you have also D complement. Alright, so D complement. So D complement is also this outside part there. Okay, so how can we report this? Okay, so the issue is, how do we report this now? Is there anywhere where they intersect? Yes, they intersect in this, because you see also come and bound outside there. Okay, so this will just give us what? D complement. Why? Because there's what? We are outside the environment, like we are adding the whole of A and B, they are making one set. But what is outside? All right, what is outside is what we are reporting. So C complement, we are reporting what is the outside, but where they will intersect, that's the region we'll pick. So we'll pick D complements, like that. So that should be our answer. Then C union D complement. So if C is on the middle there, then we unite with the D complement. Are we getting anything? This is difficult. Why? We can't report the region. Let me show you. We can't report the two regions there. Okay, we have the C and the D. The whole C is there, right? We are uniting it with what? With the D complement. This will be very difficult to trace because the region here, we still want we want to unite C, alright, C region with the outside D. How can we do this? This can't be done, because the way we can do this is only by saying this will be D complement, because it will be outside D. Okay, we add the C. It's more like in C there is 2, then outside there is 10, so we get 12. So we are just getting what is on top there. We report. So this will be just a D complement. Alright, so but otherwise you'd have just reversed the same answer, but to put D complement like that. Then for this one also, how do we handle this one then? Okay, this is question 4. How do we handle this then? What you are going to say is, we have a C there, C complement, we know it's outside there. Okay, then C union D again, C union D, we are adding everything. Okay, so C union D and C complement. So C complement is outside, so this will just give us the universal thing. Alright, this will give us the universal set, because my pen is not writing proper. What should I do? Okay, so what I'm going to do is I'll say okay, just a moment. I was replying to a message. I'm just replying to my message. Okay, so we are talking about now C complement, that is outside C, then we intersect it with the C union D again. What will be that? Okay, let me show you the clear picture here. Okay, let me just draw another diagram so that you see what is happening. Okay, let me draw another diagram, you see what is happening. Alright, we have D and also C inside there. Okay, then we have D there. Okay, so what are we getting there? So we have, I think there's something, let me judge this one before I put the inverse like that. Okay, so we have C there, intersections like that. So starting with the C complement, it's everything like that. Okay, this is C complement that I'm doing now, I'm shading. Okay, C complement. Let me just concentrate here. This is C complement, the whole this part is C complement. Then this C complement, we need to unite it with the everything again. Okay, we want to unite it with again C and intersection what? D. I mean union D. So we are adding, it's more like C and D, we are adding both now. We add them. We want to intersect the region of the addition and also this one. Okay. So where are we going to be? Okay. So you can see that the region of addition will be in this. Okay. Only it will be in this. Okay. So this means that the answer now will be C. Okay. Complement, the C complement, but where it will intersect with the D only. So that will be the answer. Alright, so that is it. So if two sets are disjoint, simplify if possible. So if they say two sets are disjoint, so what do we do? Oh, someone is calling. Hello, let me just call you. Let me just call you after like 20 minutes, 10 minutes, okay? Alright, so that is it. Now coming, if two sets are disjoint, again let me show you a picture of what is happening me. Okay, let me show you a clear picture of what is happening there. Okay, so if two sets are disjoint, alright, where am I putting the shape? Okay, so if two sets are disjoint, and can you write something inside there? No, let me just remove that. So if two sets are disjoint, what does this mean? So it is telling us to say they do not meet. It's more like we have a joint, but we don't, like, we are not meeting at end point. We have a joint there, but we are not meeting at end point. Okay, so how do we handle this then? What we are going to say is, so we have two sets there that are not jointed, okay, that are not together. So then how do we simplify the following? This can be alright, so if we are to factorize these intersections there, so that will give us A intersection D, alright, complement there. So but first of all, look at this property. When we say A, let's say intersection A, okay, that will give you A, right? Again A union A, that will give you A. Master these rules, okay? That is it. Okay, that is it. Then intersecting A plus, let's say A complement, that will be just what? The universal. So anyway, let me show you this now. Since we have written this, we are now looking at what is inside. Do these intersect? They don't intersect, so there's an empty there. Alright, empty complement, and empty complement, this is universal. Alright, hope we know this by now. Okay, that's how we'll get the answer for that one. Alright, no, wait, I've really made a mistake. I think there's something I'm missing here. Okay, let me start afresh. Okay, so here what we are doing is we have C complement intersection D complement. How do we handle this? So here you just look at the effect of this intersection. So what you are going to, the effect of this complement, I'll simplify if possible. So I'll simplify, I'll say this will be now union, alright, then D, open bracket, then that is it. I'm done, because this is the only way I can reverse this. Okay, coming to number 2 now, what will happen is these two guys, they share what we call, they are not joining. So what is inside the complement there outside, it's an empty set. So empty set complement is what? This is universal. This is the question in fact they like the most. Then coming to this one now, where we have A union B, something like that. So here will be solved as follow, where we have, we'll say, we'll factor out again this complement, and we'll say C intersection, okay, just like we did for the first one, complement like that, then we put a complement like that. So these two guys, they do not meet, so we say a complement like that, then complement, because what is inside there is the empty set, so they don't meet at any point. Then we know the properties of empty set complement, that to give us universal. Okay, so we have two universals, right? So it's going to give us two universal, because yes, it will give us a universal set. Alright, so that is it. Then coming to this one, how can you handle this? We have C union D, yes, C union D, then complement. What are we going to find? We add them, and again we still find the same thing. This can't be solved. Okay, unless if you are from like a college, that's how you can solve that one if you are from a college. So that is it about this. In fact, I wasn't supposed to solve everything just like the culture, but I'll try. Even here, what I'm going to do is I'll say, using the distributive and associative properties of union and intersections, show that. So I can solve this one, then you try to solve this. Or I can solve this and this. Let me start with number one. Let me start with number one here. Okay, so you start with where it is much complicated. So I'll say A, alright, intersection B, alright, then union, open bracket, A, intersection B. It's more like we are factoring out what is common here. Okay, so want to see if we get A like this A. So say A intersection will be used. So factor out A intersection. Okay, here what remains is the B here. Okay, then we have the union now that is in between, then again we have the B there. Alright, by the way, this B is a complement. Okay, alright, so how are we handling this then? Okay, so we have now A, okay, intersection, open bracket. Okay, so what is B union B complement? Alright, so we have a set there. Alright, we have the same set B. Okay, what is this B? The B that we have plus again the B complement, because union is more like addition, plus again the B complement, so that will give you the universe, the whole lot of the set. Then you intersect with again A intersect with the environment, with the universe, it will still intersect at A, so that will give us A. So that's how you can solve this question. Alright, so that's how you can solve that question. So let me try also the last one, so that we can see the clear picture what is happening here. Okay, let me try this one. So again we have, that is question 3. So we have A union B intersection complement like that, intersection B. You start with what is complicated. Alright, I can see on my left side it's complicated far much than on the right, so that's how I'll simplify it. So you start with that one, so you distribute here, you multiply throughout. Okay, so that will give us A, okay, union A complement. Okay, you open like that, you close, then there's an intersection there, then you say again A union B like that. Okay, so we know this property, so say what will be that. Okay, so we know this property to say A union B, just like we had here, is still the same here, so that will give us universal. Alright, universal intersecting with A union B, what will be that? They will still intersect at A union B. Okay, so hence is equal to that. You have seen? So that is it, that's the answer. That's how you can conclude this. So try this one as well. I'll be waiting to the 9. Don't be lazy. Okay, 0964 122 411, this is my line, so you submit there. Just helping you, I'm just helping you. Okay, so even this here, I'll try to simplify. I can simplify this one, still the same with the previous knowledge, and also I can simplify this so that we simplify on each other. Like for A, I'll simplify the first one. Also for B, I can choose the first one, or n of these. N I can solve. So I can start with now these curly brackets, these square brackets. So we have x complement union y complement like that, then intersection z like that. Okay, then close like that. So how do we start with this then? Okay, how do we handle this? So what you are going to do is, okay, you cue these curly brackets. Of course there's something that they left here. This question would have been spiced more than this. So we'll say x complement, alright, complement, then union, alright, y. Okay, then what I'm going to do is I'll say now intersection. Okay, intersecting now with again x complement union z. I think this one can't be simplified further. Alright, union z like that. So we can't go far much unless if you want to complicate some things, whereby we can say we assume one set is not like the other, then we'll be able to stand with this pressure. But for now, you just leave it like that. This one is not going anywhere. So but for this one you can still simplify, because I can see this and this, which they will give you the universal, then you intersect it with what? X, and that will give you something like x for this one. Okay, then let me try for this one then. So here let me say 1, we have x, okay, intersection open bracket x complement union y like that. So we intersect, we distribute what is inside with what is that. So say x intersection x complement, alright. So this is what we have there. Then we have also union open bracket x intersecting with y like that. So x intersect with x complement, okay, something intersect with nothing, that would just give us nothing, okay, which is the empty set. Then x intersection y. So nothing plus something, that will still give you something, which is x intersection y like that. Okay, so that's how you can solve. So try to solve this one, this one, and this one. This was somehow complicated. Why? Because of 3 sets that are involved, and you can't eliminate any of these unless if we assume some conditions. We can eliminate one. Okay, so for this one I'll just solve this one, then you solve this one and also this one. Okay, even equally this one. So that's what we will do. Okay, because of in the interest of time. Okay, that is it. So we have now, you come up with a Cartesian plane like that. I don't know if it's a Cartesian or a number line. Then what you do is you look at the universal first. Let A be equal to and B shan. So the universe will be given from A set A and from set B. So set A start from -4 to 2. Okay, then set B start from, okay, set B just -1. Alright, okay, it's just starting from -1 to greater than. Okay, so what you are going to do is the least negative number I have is -4. Okay, then do we have any negative there? I still have -1. Okay, then what else? Do you have any negative? No, we don't have. So the positive that I can have, again, I'll say this is 2. Okay, that's the only positive I can see. So to plot A, even plotting these are just marks. To plot A, I'll say this is what A has -4 to greater than. Alright, so A has -4 to 2. Okay, so A has these the following. Alright, so it has on 4, it is also touching, it is closing, meaning that is including, and it is not including, it's not including 2. just like that, it's less than. Okay, then coming to B, we have -1, which is included. All right, -1, it's included. Then all x's are greater than -1, so all x's, they are equal or greater than -1. So what I'm going to do is I'll say all x's are going like that. Okay, okay, there's an arrow pointing there. Okay, so if we were to solve this one, okay, if we were to solve this one, how can we handle this? Okay, let me just make the board gray. How can we handle this then? So we can see that A complement, okay, A complement now will be, so I'll solve the 2. So say now A complement, okay, so we'll say A complement, it will be the region, A complement will be the region from here. Okay, let me put it black there. So A complement, this was set A, right? This is set B. Okay, so I'm going to say A complement is now this region. A complement will be 2 wasn't part of A, so I'll say A complement now it will cut at 2 and going this side. Then here again A complement, it will be now open, alright, because 4 was the part of what? The complement. So that's how it will be affected. You have seen? Alright, so that's how it will be affected like that. Okay, so that's how it will be affected. So now how do we list this? A complement will be, alright, A complement will be so say A complement, this is equal to, you have seen there's an infinity there that we can't see, alright, then comma -4. Okay, are we closing for -4? Someone to answer in the background there. Okay, yes, it's not part of it. Why? Alright, okay, so yes, so the infinite part we don't know where it will end. Okay, so this means that we are not touching the 4 because it was part of the intersection at first, right? I mean, it was part of A, so we are not touching it at all. Okay, so that's the A complement. Are you able to get me? There's lane, so that's why you can't get me clear. I can't also get you. Please increase the volume. Okay, okay, it's okay. So this means that 4 is not part of what? I mean, I don't have to write it like that. So we have A complement like that there, okay, and also here A complement like that. So A complement here, it's scattering at 4. At 4 they are also open like that. Then we'll say union, we add with where we start from 2. So 2 now wasn't part of A, so we can now include it. Okay, then All right, we can now include it like that. Then on this part also there's also infinite. Okay, so infinite can't end. So what I'm going to do is I'll say I'm going to do this. I'll say we have infinite, positive infinity there. Okay, so are we ending at infinity or not? Someone to answer, please. Someone to answer, I'm listening. Okay, 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 let us see. So we can see that we can see that infinite we have positive infinity there, so we don't know where we'll end. Okay, so we don't know whether a positive infinity will be also part of it, so we'll end just at this point. Okay, hope that makes it clear. Let's talk about now A intersection B. Where do they intersect? We can see they intersect in this region, right? A intersection B. Okay, A intersection B intersect in this region. Okay, so that is it. A intersect in that region. So this means that this will be equal to, say, A intersection B. A intersection B will be equal to, first of all, we are getting this point which is -1. In the intersection is embedded for everything, so -1 is part. Okay, comma, what is this now? 2. Okay, is 2 part of A? No. Is 2 part of B? So I've made a mistake the way I made B. So this is now challenging. Okay, this B ends to whatever infinite, and A is not part. This 2 is not part of A, and again this 2, it can be a part of B or not. Okay, because B will end at infinity. So this means that B was still going there. All right, B was still going there. Okay, so this means that 2 will be included. Why? Because we can't leave it. It wasn't a part here, so meaning that it will take part in the next move. So that's how we'll present this. So try to, it's noisy here, but I'm trying my best. Try to solve this one. You can pause it and solve it, but here it's more like A intersection X complement, like that. That's the meaning there. Okay, even equal inside there you say Y intersection X complement, like that. Okay, so that is it. So try to solve this one now. Okay, then solving this one, I'll give an example then so that you can solve for the first one. All right, I'll give an example so that you can solve for the first one, then we'll be able to conclude things there. Okay, I'll solve each scenario here. So here I'll get the first one, so I'll say the first one. Hope you are getting me. So the first thing that you need to do is, when solving these questions, you say you do this. You say we have 0.33. Okay, the first thing that you need to do is make sure that all the numbers that are not in the bar are brought to your left. That will be your equation 1. Okay, so this, the way it is, it will be my equation 1. Okay, then equation 2 will be at least all of these that are in the bar comes also to the left again. So that will be multiplied by what? By, you can say multiply multiply 1 by what? by 100 so that you get, in fact it's 1000, so that this point can come there. Okay, so that will be 0 point, I mean not 0 point, when you multiply times 1000, that will be 33 point. Again, there were a lot of threes, that's the meaning of 3 bars. I've just chosen these two and brought them there. Okay, so that is it. So that will be our equation 2. Then subtract equation 2, I mean equation 1 from equation 2. Alright, so that will be 3.33 bar, like that. Okay, so this means that we had equation 1 as 0.33 bar, like that. Okay, so from there, then when you subtract, that will just give you 33. Right, is that okay? That's how it was. So that would be just the 3 bar. Anyway, there was a point after, so that could be the mistake. Alright, let us try this one then, and we see what will happen. Okay, but this is supposed to be a fraction. Why is it like this? Okay, let me show you something here, something important. There's something important that you need to know here. Okay, there's something important that you need to know. Suppose now, the way it was now, okay, this came from, so let me show you something. Suppose I'm dealing with the question 2. I just want you to actually calculate something. There's something that I want us to communicate there. Alright, so when we have, let's say 0.16, just like that, 16 bar there. So what we do is, first of all, we'll say this is our equation 1. Okay, this is our equation 1, and we'll call it equation 1. Alright, because the goal that we want is to make sure that is what is outside the bar should be inside the bar. Alright, I mean what is inside the bar should at least come out of the bar. So I don't know how they arrange these questions, but this is how they should move. This is an exam question. So for this one also, it will give us the same. I've seen already. So what you do is, the first law, what you need to do is, you make sure that the point here comes on the left there. Okay, so once it comes on the left like that, that means that there were a lot of 6 bars, so it will come as, we multiply times 100 there. Okay, so that will be 16.16 again bar, like that. You have seen? So we have chosen these ones, so this will be now our equation 2. Okay, so doing this, it will still again subtracting 2 minus 1, it will still give us 16. Okay, so I don't know what is happening, but that's how they were supposed to arrange the question, but it is coming like this. Okay, it's coming like this. So this means that there's something there. Okay, they should just come like this, there's no problem. Okay, so let us now try this one. I see how it will come out. Let me try the other one, we see how it will come out. Okay, this one I know it will come out properly. So this is an exam question, also this is an exam question. Very careful. Okay, so be very careful. Alright, be very careful. So I need to solve these questions properly. Let me do the other way around. Let me pick this one. Okay. So what I'm going to do for these ones which are just direct, I think let me try to do this. That's the best way. Let me get the first one there. Get me clear now. We have 0.33. These ones you don't have to follow that format we were doing. It's direct. So long as there's no independent number here, it's direct. Okay, you just divide that. Okay, you divide that. Okay, since these are just direct, I said they are direct. So what you do is you say you multiply times 100, right? You divide by 100 for you to move the point. So you have 3. Okay, then what is that? 1000. The point will come there, right? So that will be, the point will be 33.33 bar, like that. Okay, okay, then from there we are now subtracting. All right, we are now subtracting. We'll say, in fact, whenever you see these or these, like if like this and this, just put over 99 over 99 and then everything will be okay. So whenever you see this, just put over 99 99 99. Whenever you see it's just having 1, just put 99. That's all. That's the key I'll tell you. Just put 99 whenever you see. Whenever you see just there's no independent number in front there, like this, you can put 99, unless if there's a coefficient like that. But for all these, just put 99, like 0.33 bar. This will be just written as 33 over 99. You can simplify this to what? You can simplify this to 1 over 3, right? And then where there's 6 also, 0.16, you can also write this as 16 over 99. Okay, then that will give you what? I think you can simplify this further, so it will end there. Alright, but for these ones which are just like this is where now we need to do the most. Let me show you this, then you'll be able to solve, because the rest will be now the examples of this. So now for question, is it question 3? So we have 2.143. Okay, in the interest of time, so all these are in the bar. So the first equation that you need to make is make sure that at least what is inside the bar comes on your left. So that will be, you multiply times 1000 times what? 1000, right? So you multiply times 1000. So that will be, so this is our equation 1, right? Equation 2 will be, we'll have 214 when you multiply times 1000. Then the point will come there. Then again we'll have 143, because there were a lot of these in the bar. So that will be our equation 2. So you subtract now equation 2 minus equation 1. So that will give us 2143.143 bar. Okay, so that will be equation 1 to be 2.143 bar. You subtract like that. That will give us, let me just punch on my calculator, but we can see this is 0, so that will be 2, so that will be 2 point. Alright, we multiply times 1000, right? We multiplied equation 1 times 1000. Okay, I've seen where I've been making a mistake. I'm sorry guys, I've made a mistake there. This is where I'm making a mistake. Yeah. So if you say x, let x be equal to the same thing, 2 point. You've seen where I've been making a mistake. This is the format that you need to follow. Okay, then all these are in the bar. So you multiply this x, so this will be our equation 1. You multiply this x with what? 1000. So that will be 1000. So equal, that's what you are supposed to do to these. I've really made a mistake, I'm sorry on that one. So 1000, then what you do is 1000, you multiply 1000 times that, x, okay, is equal to, then it will be 2143 point, again 143 bar, like that. Okay, so you subtract. Now once you subtract here, you have 999, like that. Okay, so x is equal to, when you subtract that, I'm just subtracting, this is my equation 2, so I'm subtracting 2 from 1. Okay, so that will give us, the 2 cancel there with, that will be 2142. So you divide that times 1000, I mean times 999, so that will be x is equals to 2142, like that, over 99, like that. So you can still simplify there, but for me I'll end there with 1. I think 1 can go. So that's what you are supposed to do if even equal with that one. So you would have said let x be equal to 0.33, okay, bar, like that. Okay, so you multiply times 100 so that this point can move there. So that will be, this will be your equation 1. Okay, so what you do is x, you multiply times 100, that will be 3 bar, then 3 like that. Okay, so from there what you do is, this and this can go if you subtract equation 2 minus 1, so that will give you what, x is equals to 3 over 100x minus x, that will be 99, so you put 99 there. So that's what I meant when I say whenever you see 2 digits, that's put 99. If there are 3, you put 999. Okay, that is it. So proving this is not that hard. I think I can demonstrate this, but in the interest of time, okay, let me try to demonstrate one, then I call it a day. Now the video, I don't like long videos. Don't like long videos. Okay, so I'll solve this one, so that, because these ones, they are just direct, they have already given a statement, so that won't be a hard thing. Alright, so let me say, okay, prove that root 3 is actually irrational. So we say proving by contradiction. So you write this statement always by contradiction. Please always write this, proving by contradiction. So what do we do in proving by contradiction? So we say proving by contradiction, that's the first statement. You even underline if you want. Okay, so what we do is, in the proving by contradiction, we write a lot of, so you suppose now you write, we assume root 3 is rational. Okay, it can be written in the form of a over b, where b is not equal to 0, and a comma b are co-prime. Okay, or they do not have, they are in their lowest factor, simple, I mean common factor, like the only factor that can be between them, it's 1. Okay, so this is what will contradict. Now we are here to make that statement. Co-prime simply means they don't have, like, the lowest factor they have is 1, so they are in the lowest factor. Okay, so what we do is we say root 3, okay, is equal to, let's say we are equating it to the rational, which is a over b, with the statement I gave, a over b. So this means that we have to square this to remove that. Alright, So that will be, we have 3 there. Alright, once you square that, then that will be a squared then over b squared. Okay, then from there, this means that a squared is equals to 3b squared. Okay, alright. Okay, so that's the meaning. This means that, okay, this means that a, okay, a that we have, a squared here, is divided by 3, is divisible, right, by 3. Why do I say so? If we have something that I'm multiplying, it means they are factors of that thing, like 3 times b squared to get a squared. This means that even 3, it can go, it's more like 12 times, 4 times 3, that will give you 12. 3 is a factor of the same 12, you see? That's the meaning there, in case you have not been getting it. So it's divisible by what? 3, okay? Also a, also the same 3 is a factor of a, okay, because we can see that this is a square, right, even, and this one is a factor. It's a quotient. This means that the same quotient can go into the what? Into the same a. It was squared, it means it can also go in the single a. Alright. So that's the meaning there, in case you have not been getting it. So I'm trying to do this so that you get the concept. Okay. So meaning that there's something that exists that will be governing this equation. So say there exists a factor k. So that what we'll say is 3k, there will be a k there. These 3, there must be a k factor there. That will govern our a squared. Okay, our a, So from there, what you are going to say is, since this is the relation between a and the 3k that we don't know, whether k it's 1 or what, we don't know. So we'll go substitute where there is a squared there. So I'll say, I'll put 3k squared is equal to 3b squared. Okay, so once I square that, will be 9k squared is equals to 3b squared, like that. Okay, from there, what I'm going to do is, I'll say at this point, this is also where I'll quote again to say, I can simplify this, divide by 3, that will be 3k now squared is equals to b squared. You have seen? So again, we are giving the same quote there. We are giving the same quote to say 3. Alright, 3 is a factor. We can see there, to get b squared, we multiply 3 times k squared, meaning that 3 and k, they are factors. So once you multiply them, you get b squared. So 3 is a factor of b squared. Okay, then again the same 3 is also a factor of b just. Okay, so since 3 is seen as a factor of both a and b, so this is the conclusion that we are giving. Since 3 is a factor of a and b, okay, this contradicts our assumption that they are co-prime. Okay, they don't have a common factor except 1. So this contradicts our earlier assumption. So you write that. I don't have time to write that, but you can write that. So since a and b have a common factor 3, this contradicts our earlier assumption that A and B are coprime. So you have seen the contradiction. So that is it. Alright. So for this one, this type, we have already told you to say this is the rational. Alright, so the way you handle this, let me show you. What you do is you say, let me show you the answer here. So you have, again, you say we prove by contradiction. Suppose this one is the rational. Okay, so it can be expressed in the form of A plus 5. It can be expressed in the form of A over B, where B is not equal to 0. Okay, and A and B, they are just integers, numbers. So what we do is we take this one to the other side. That would be root 3 is equal to, okay, that would be A over B minus 5. You make this as a fraction. That will be B, okay, that will be A minus 5B. Okay, so this means that we have root 3 is equal to A minus 5B. Okay, then we have B there. Okay, so that is it. So from here to end, this one ends here. We can see that root 3, they have said it's irrational. So since root 3 is irrational and A and B are factors, this means that this part is irrational. So irrational can't be rational. So this contradicts our assumption that it's irrational. So this side we have rational part, then this side is irrational. So rational can't be equal to rational. So this actually should be the meaning here. So you know how to solve this. I'm just trying to remind you. Okay, so the last part here, this type we have solved. Then these are just, I'll solve also this one, then come to one equation as well. So absolute value simply means the distance that is on the number line. So the distance, let's say we have -1 to to 1. Can you report the distance going this side as -1? No, you report it still as 1. So that is it. So if you find -1, multiply with the negative so that you get a +1. Here if it's just positive, multiply with positive, still get 1. We just want the distance on the number line. So that's the meaning of absolute here. So you are getting two values. So we have absolute value of x minus 2 absolute is equals to 6. So we have the first one, which will carry the positive part. That will be x minus 2 then is equals to 6. So that will be just x is equals to 8. Okay, then the other one will be negative x, okay, minus 2 is equal to 6. So this will be negative x minus, that will be plus, now 2 is equals to 6. Okay, that will be negative x. Once we solve that, that will be 4. Alright, so that will be x is equal to -4. Okay, these are the distance we can find on the number line. Okay, and when you substitute there, it will still give you the same. Alright, that is it. So that's how you can also handle this. Even get two answers, find two answers. Alright, find two answers, but they shouldn't equate it to a negative number, because it can't be equal to a negative number. A distance should always be positive. So if you see a negative is equated to, these absolute values are equated to a negative, just know that that won't give you the answer. Alright, all these, they will give you answers. So for this one, you report just as 4. That's all. There's nothing like whatever to do here. Just report as 4. The distance, we just want the distance. Okay, unless if there's a variable, that's when you equate 2 times. Then for this one also, I can solve this one, number 10. So that will be x minus 1. So what you do, you square this to kill these absolute values. Okay, you square. Okay, then we have also this side also we square plus 1. Okay, so squaring this, that will give us x minus 1, again x minus 1 less than again x plus 1 again x plus 1, like that. So this means that we have x squared there. Alright, the next time that will be negative x, then again there negative x, then that will be just 1. Okay, then less than, like that, greater than. So we have x squared, okay, that is plus 2x then plus 1. If you do the manipulation there, that will be x squared minus 2x plus 1. Okay, then again less than, we have x squared there plus 2x plus 1. Okay, we can see this one and this one has gone. Okay, so that will be this one and this one also has gone. So we must have something here. Okay, we need to get a value. I think I've done something wrong with the calculations. Yes, okay, let us see. So that will be negative 2x then is less than 2x. So once this one goes on the other side, that will be a positive. Okay, that will be 0, so it will say negative. Alright, or let me make it a positive. So this one will go there, so we'll have a 0 less than is equal to what? 4x once this one crosses. So that means that x is greater than 0. Okay, so wherever you put, alright, x should be greater than 0, but this is not true. This is not true. Let me divide properly. So we take this one to the other side, that will give us negative 4x. Okay, then the negative looks like this. Okay, then we have a 0 there. So we divide throughout by negative. Whenever I divide by negative, this one changes. So we divide by negative 4 there, that will face to like this. Okay, so this means that whenever we need to put numbers that are less than, that are negatives, for us to maintain this relationship. So this actually is correct. So that's what we need to do here. Even here you can solve equal, you square this, then here it will be 9, then you start solving it. It will give you obviously something like x is greater than 7, something like that. So that's how you can solve this one. This marks the end. I don't like long videos, I'm even tired, so I'll make sure that next time I just get the part. Alright, thank you very much.